So we have one more section in chapter 4 that we are going to review. So we're going to kind of jump more into this idea of what's a function, what's not a function, those kind of things. So we introduced the idea of what's a function, what's not a function on Monday. So whenever I talked about this on Monday, I talked about the idea of the high for the day. So the high on Monday is 72. The high on Tuesday is 60, or whatever it may be. But there's only one high temperature for the day. So I said that's a function because every function, every input has exactly one output. So another example, I think this one clicks a little bit better with students, it's what I call the birthday function. Okay? So here's how the birthday function works. So we've got our function machine. Xavier's birthday?
Yeah.
Okay, so we're going to put Xavier in the birthday function. Happy birthday. And here's how the birthday function works. You put somebody in the birthday function, it asks them their birthday, and it spits it out. So if we put Xavier in the birthday function, it would say October 21st. Happy birthday, okay? If you plug me into the birthday function, it would spit out February 5th. If you plug Thomas into the birthday function, it would spit out October 15th. Okay, so we kind of understand that birthday function, you put people into the birthday function. The rule is, what is their birthday? And it spits out their birthday. Now, the reason why I like this to kind of visualize the idea of what's a function and what's not a function is when you put somebody into the birthday function, it is going to spit out exactly one birthday. It is absolutely not possible to put somebody in the birthday function and it spits out 2 birthdays. Right? Nobody that you know has 2 birthdays. That just wouldn't be fair. And actually, when you get to my age, you don't want 2 birthdays. One less birthdays, right? Maybe one every 2 years or something like that. So anyway, so one birthday. Each person that goes in the birthday function gets exactly one birthday out. Okay? You couldn't, like I said, you couldn't plug somebody in and spit out 2 birthdays. It doesn't work. But what can happen, is why I really like getting the birthday function. So you may know somebody who shares the same birthday as you. Me personally, I have 2 cousins that have the same birthday as me. Okay, so me, my cousin Liz, and my cousin Jeannie. So if you plug me into the birthday function, it's going to spit out February 5th. You plug my cousin Liz into the birthday function, it's going to spit out February 5th. You plug in my cousin Jeannie into the birthday function, it's going to spit out February 5th. That's still a function because every one of us going into the birthday function, it's still just spitting out one birthday. It's just spitting out the same birthday. That happens all the time. So you can put different things into a function and it can spit out the same thing. You can get the same answer for different things, but what can't happen is you can't put something in and get out 2 answers. Okay? Does that kind of make sense? Do we see the difference? Okay, one person can't have 2 birthdays, but 2 people can have the same birthday. Okay, so we're going to kind of use that idea to look at some relations and decide if they are functions or not. So most of the time, functions are not talking about birthdays and days of the week and high temperatures. They're usually ordered pairs. Because most of the time when we talk about relations and functions, we're talking about an equation, okay, a rule. So an example of something that would be a function could be something like 3, 2. Which, remember from the last few days, what this means, I don't know what my rule is, but I know I plugged the 3 into I don't know if it's a function yet, but I plugged 3 in, I did something with it, and my answer was 2. Okay, I plugged 3 in, the answer was 2. Okay, then I plugged in 2, and I got out -3. And then I plugged in 1, and I got out 0. And then I plugged in 0, and I got out 2. So once again, I don't know what the rule is. It doesn't matter what the rule is. But this is what's happening here. This is a function. Now, the one thing that gets people like, yeah, really doesn't look like a function is the fact that 3, when you plug in a 3, you get 2. And also, when you plug in a 0, you get 2. That's okay. That's still a function. That's like 3 and 0. Put them in the birthday function and have the same birthday. People have the same birthday all the time. That's fine. That's still a function. Now something that would not be a function would be something like this. 3, 1, 3, 2, 3, 3, 3, 4. That would not be a function because what's happening here, some rule says, okay, if you plug in 3, you get 1. Okay, but then the next time I plug in 3, I get 2. And then the next time I plug in 3, I get 3. And then the last time I plug in 3, I get 4. This is taking 3 into the birthday function and saying 3 has 4 different birthdays. You cannot have 4 different birthdays. You have 1 birthday. Okay, so function, 2 things can be mapped to the same thing, right? Where we had 3 and 0 both mapped to 2, that's fine. That's like these things sharing the same birthday. But where you have these same thing mapped to 4 different things, that doesn't work. This is like 3 having 4 different birthdays. You can't have 4 different birthdays. Okay, see the difference? Okay. Now, if you have ordered pairs or a table, or what we're going to talk about later is a mapping diagram, this is what you're looking for to tell if it's a function or not. Now, sometimes today, you're going to be actually given the graph of a relation, and you're going to decide if it's a function or not. These are really, really easy to tell if they're functions or not. If a graph is a function, it has to pass what's called the vertical line test. Super simple. It just means that you need to draw vertical lines through your points. If it crosses at any point more than 1 time, it's not a function. Okay? So like this one right here, the points that were plotted were here and here and here and then here. So I can draw a vertical line here and it just crosses through that 1 point, no problem. I can draw a vertical line here, crosses through that 1 point, no problem. Same thing here, it just crosses through that 1 point, no problem. But when I go over here, see how that vertical line crosses twice, goes through 2 points? Since this fails the vertical line test, this is not a function. Not a function. Because think about what these points mean. These points mean, this is the point 1, 2. It means that I plugged 1 into my function. I got 2 for my answer. I plugged 0 into my function. I got -2 for my answer. I plugged -3 into my function. I got 1 for my answer. But when I plug in -4, sometimes I get 2 and sometimes I get -1. This is like -4 being mapped to 2 different things. That can't happen. Okay? Now, most of what and then this is an example of one that does pass a vertical line test. So if you look at this one, you could draw vertical lines anywhere you want on that parabola, and it would only cross 1 time. So this is a function. So this will say this one is a function. It passes the vertical line test. Now, most of what we do today is very simple, okay? The stuff that we do today, I think that's trickier, is actually stuff that we've already done earlier this week. Just looks different, because today we're going to use what's called function notation. And function notation looks like this. So, what this says, how you read this says f of x. That's how you say that, f of x. Now, that doesn't necessarily have to be an f. Sometimes it's a g of x. Sometimes it's an h of x. Sometimes it's a p of x. It could really be any letter, okay? What this f of x means, and this is the new part, this is the part that's different. Normally in math, whenever we see a letter, usually it's a variable, but f is not a variable. F is the name of the function. It is the name of the function. And one reason you can use function notation is because it lets you name the function. So if I have multiple functions I'm dealing with, normally I have to say, okay, use this equation here or this equation here. Or if I use function notation, I can say, okay, we're going to use function f, or we're going to use function g or function p, but they have names, so it's easier to identify them. Okay, that's one reason to use function notation. Now, if we keep moving over here, f of x, the f part is the name. The x is going to be the input of the function. The input of the function. Whatever's in these parentheses here, That's what you are plugging into your function. So I'm plugging x values into the function, which is usually what we do, right? We plug in x values and it spits out answers. A lot of times what's going to happen is they're going to replace this with a number. Whatever number's in here, that's what you're plugging into your function. This number right here is your input. Okay, now, when you plug in these x values or these numbers or whatever's in those parentheses, you need something to do with those numbers. You need a rule, like we did on Monday and Tuesday. This right here, the 3x plus 4, that's the rule for the function. The rule for the function. So this function, you're going to plug in x values. Whatever you plug in for x, you're going to multiply it by 3, and then you're going to add 4. What your function spits out, we typically call it a y value. That's what we did Monday and Tuesday, is we plugged in x values and it spits out y values. This time, your function, you're going to plug in x values, and it's going to spit out these f of x values. Okay? What f of x means, or what f of x does, f of x is the value of f when the input is x. It's the value of f when the input is x. The value of my function when I plug this in. So, for example, maybe I have a function that says c of a. C of a, okay? And maybe c of a is 10, okay? So maybe function c represents the total cost of something. Maybe it's the total cost of apples. I'm making something up here, okay? So when you find c of a, the total cost of this many apples is $10. The value of 10 apples, or the value of this many apples is $10. That's what function notation does. It kind of takes something that you normally have to write in a big sentence into kind of a condensed version there. Okay, we'll kind of talk more about that tomorrow. Okay, questions on this? Yes.
What does it say after in
The value of f when the input is x. Okay, I'm almost positive this is our last section in our review. So this should be on page 47. This is section 4.6, Formalizing Relations and Functions. Okay, most of what we do today, really simple. And then the stuff that looks difficult, it's actually easy, it just looks different. So the first thing we're going to do, we're going to look at a relation. We're going to identify the domain and range. Then we're going to use what's called a mapping diagram to determine if it's a function. So the relation I'm going to give you is in the form of ordered pairs. So number 1, we're going to do 4 ordered pairs. So let's do 1, 3, 2, negative 3, 3, 3, 4, negative 3. So what we want to do, we want to identify the domain and range. So if you remember, the domain, these are the things that you're plugging into your, it's not necessarily a function, but these are the things you're plugging in, okay? So remember 1, 3 means you plugged in 1 and you got out 3. So when I'm identifying my domain, 1 is in my domain because that's one of the things that's going into my rule. The next ordered pair says, okay, well I plugged in 2. It's like a bracket. I call it a curly mustache bracket. I'm just not very good at drawing. Okay, I plugged in 2, I got out negative 3. So 2's in my domain. I plugged in a 3 and I got out 3. And then I plugged in 4 and I got out negative 3. So the numbers that you plugged into your rule were 1, 2, 3, and 4. Your range is going to be, okay, well, when you plug in 1, 2, 3, and 4, what do you get for your answers? Well, when I plug in 1, you get 3. When you plug in 2, you get negative 3. Now, when you plug in 3, you get 3. I already have the 3 written, so we don't need to write it again. And when you plug in 4, you get negative 3, which I already have written, so you don't need to write that again either. So we have our domain, we have our range. What we're going to do next is we're going to do what's called a mapping diagram. I do my mapping diagram as bubbles. Some students in the last class like to do it as a table. That's fine, it doesn't matter. What you do need to show is that you're going to group the numbers that are in your domain and you're going to group the numbers that are in your range. So in my domain bubble, I'm going to write 1, 2, 3, and 4. Those are my domain values. And the only thing in my range bubble are 3 and negative 3. And the mapping diagram is really simple. You're going to go back to your ordered pairs, and this says to map 1 to 3. So you're just going to draw an arrow from 1 to 3. You're going to map 2 to negative 3. You're going to map 3 to 3, and then 4 to negative 3. That's a mapping diagram. Mapping diagrams are nice because it's really easy to tell by looking at the mapping diagram whether it's a function or not. Remember, if it's a function, everything in your domain has to be mapped to exactly one thing. Everything in this bubble can only have one birthday. Is this a function? Yes. Okay, now if you're not sure, you're like, I don't know, what about the 3 and the negative 3? That's like 1 and 3 sharing the same birthday. People have the same birthday all the time, right? That's fine. That's no problem there. This would be, this would be a function. Okay, number 2. Let's try another one of these. Number 2 says 6, 5, 4, 3, 6, 4, 5, 8. So, going to do the same thing. Want to identify the domain and the range. Remember, the domain are the things that are going into your rule. What is something that's going into this rule? 6. What else? 4. And 5. 6, 4, and 5, right? I know I have 6 right here again, but you don't need to list it twice. It's the same 6. Okay. Now, whenever I plug in 6, 4, and 5, what do we get out for our answers? 5, 3, 4, and 8. It's just the Y values. Okay, and then we're going to do our domain bubble and our range bubble. My domain bubble just has 6, 4, and 5. My range bubble has 5, 3, 4, and 8. And then we will map them 6 to 5, 4 to 3, 6 to 4, 5 to 8. What do we think? Is it a function?
No.
No. Why not? 6 has 2 birthdays. You can't have 2 birthdays. You get exactly 1 birthday. There we go. Okay, so that's the first thing you have to do on your homework. Pretty simple. Yeah? Okay. You are going to need to copy down these 2 functions. So first, the first function is going to be f of x equals 3x minus 1. So you need to copy this down. F of x equals 3x minus 1. And g of x equals negative x squared. We need those 2 functions. You don't have to copy down the rest of the directions if you don't want to, but you do need f of x equals 3x minus 1. G of x equals negative x squared. So what we're going to do here, I have 2 functions, and notice, I don't have to say, okay, the first function or the second function because they have names. I have function f and I have function g. So for number 3, if I want to find f, of -3, I hopefully don't have to think too hard about which function I'm going to use, because it tells me use function f. Now remember what this means. I want to find the value of f when you plug in -3. -3, whatever's in those parentheses, that's what you're plugging into your function. Now I need a rule. Luckily, my function tells me f of x. To find f of x, you're going to take 3x minus 1. So when I plug in -3, I'm going to take 3 times -3 minus 1. 3 times -3 is -9. -9 minus 1 is -10. Whatever's in these parentheses, that's what you are plugging into your function. Okay, number 4, we want to find g of -4. Okay, now you need to be really careful with function g, because if you look at function g, to find g of x, to find the value of g, when you plug in an x value, you're going to take -x², and you have to follow order of operations very carefully, because you have to do the exponents first. So whatever you plug in for x, you're going to square it. Then there's still a negative sign out front, so it's going to look like this. When you plug in -4, if I plug -4 into my function, I'm going to square it. -4 squared, -4 times -4 is what? A positive 16. But all I've done so far is squared it. I need to tack that negative sign on in front of it. So it's going to be -16. Be really careful with that g of x rule. Okay, number 5 is going to combine both of these. Number 5 says we want to find f of 0 plus g of 3. F of 0 plus g of 3. So you're just going to kind of do this in two pieces. I first need to find f of 0. I need to find the value of f when I plug in, remember whatever's in the parentheses, that's the number you're plugging into your function. When I plug in a 0, we're going to take 3 times 0 minus 1. That's the rule for function f. So 3 times 0 is 0. 0 minus 1 is -1. And then to find g of 3, I need to find the value of function g when I plug in 3. You're going to take a 3 and drop the 3 into your g function. This one right here. Now remember, this is the function you have to be careful with, because the first thing you're going to do, whatever you plug into your function, you're going to square it. You take 3 squared, which is 9. But that's not the only thing the rule says. It says you also have to make it negative. So it's going to be -9. And then what I'm going to do is I'm going to add these two things together. -1 plus -9 is -10. Okay, last one of these, number 6. 4 times g of -3. So kind of like the last one, we're going to do what we can first. So 4 times g of -3. I can't really multiply g of -3 times 4 until I know what g of -3 is. So the first thing we're going to do is go to function g, and we're going to plug in a -3. Remember, function g says you're going to, whatever you drop in there, you're going to square it. -3 squared is a positive 9. But I also need to throw that negative sign in front of there, so it's actually a -9. And then we're going to take 4 times that number, which would give me -36. Questions about the function notation? Okay, the last thing we're going to do, it's almost the same thing, and it's actually super insanely similar to what we did on Monday and Tuesday. So number 7, we're going to have function g of x equals -x cubed plus 4. So we've got our function g. We want to find the value of function g when I plug numbers in for x. Here's my rule. Be careful with this rule because it's kind of the same thing. We're going to cube the x, then throw a negative sign in front of there, and then we're going to add 4. Now what we're going to do is we want to find the range. Remember, the range are just the things that are coming out of your function machine. Okay? When you plug things into your function, the things that come out, that's your range. So I'm also going to give you the domain. And the domain for this one's going to be -1, 0, 1, and 2. All this means, these right here are the numbers that are going into your function. You're going to plug -1 into your function. You're going to plug 0 into your function. You're going to plug 1 and 2 into your function, which is exactly what we did earlier this week. We did this earlier this week. We just didn't use function notation. So since I'm going to be plugging different numbers into the same function, I think probably the easiest thing to do would just be to make a table, like we did earlier this week. So on our table, we're going to have a column for our inputs, what we're plugging in for x, our domain. My rule is -x³ plus 4. Now, on Monday and Tuesday when we did this, it spit out y values because we were going to graph it. But these aren't y values. These are going to be g of x values. We're going to find the value of g when I plug in those x values. And we're going to plug in -1, 0, 1, and 2. So when I plug in -1, remember you have to be really careful with these rules because the first thing I'm going to do is cube whatever I'm plugging in. So I need to take -1 cubed. -1 cubed is -1 times -1 times -1. What kind of answer is 3 negatives? Okay, so that gives me -1, but I have to tack another negative sign in front of there, so it's actually a -1. Kind of. What is the -1? Yeah, it's a +1. So it's going to be +1 plus 4, which is 5. And then I'm going to take 0 cubed. 0 cubed is 0. My rule says to make it negative, but -0 is just 0. And then lastly, add 4. 0 plus 4 is 4. Okay, then I'm going to plug in 1. My rule says you have to cube it first. 1 cubed is just 1. But the rule, remember, there's that negative there, so you're going to take -1 plus 4, which is 3. And then lastly, you're going to take 2 cubed. 2 times 2 times 2 is 8, but remember, you got to make it negative. -8 plus 4 gives me -4. So your range are these numbers here, 5, 4, 3, -4. I know. But if I would have plugged a -2, it would have fit. Any questions?